Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 2529. Maximum count of positive integer and negative integer. Given an array nums sorted in non-decreasing order, return the maximum between the number of positive integers and number of negative integers. Okay. In other words, if number of positive integers is in nums is POS and number of negative integer is NEG, then return the maximum of positive and negative. Okay. Note that 0 is neither positive nor negative. So they are asked us to return the maximum count of either positive or negative, which has a maximum count. We want to return it. Okay. Just look at it. See here in this example, how many negatives are there? I can say this is negative, and this is also negative. So there are three negatives. And how many positives? These three are positives. So what's same? So we can return anything. So output is 3. Fine. Now see here. Here there are totally 3 negatives. And then only 2 positives. Don't take zeros. So 2 positives. So you will return what? 3. Fine. Now see here. These all are positives. All are positives. So what is output? It is 4. That's all simple. Okay. So how to approach this problem? The first step that comes into my mind is just go upon all the elements. Go upon all the elements. Just traverse. Just traverse and check whether the number is positive or negative. Okay, how to find it is positive? Whether it is greater than 0, it is positive. If it is less than 0, it is negative. S. So we will find whether it is positive or negative, and then we will increment the count of positive and negative. And then the third step is return the maximum of this both. Return the max of this both. Fine. So this is what my first approach. Okay, fine. So this is my first approach. What is the time complexity and space complexity? I can say time complexity is we are just traversing one by one. So totally we will traverse O of n elements. Sorry, n elements. So it is time complexity is O of n. What is space? It has no auxiliary space. Yes. So it is O of 1. Right. So this is my first approach. And then what is the second approach? Let's just see about the second approach. Can we optimize it? Can we optimize it? Because it is a sorted array, right? It is a sorted array. So we can use a binary search approach, right? But how we can apply that binary search approach and where is a clue? Let's see. I can say array like this. Just observe this is array. Okay. I can say if I know the ending of the negative value, I can say the start to that ending of a negative value is a count of that negative elements, right? And then if I know the start of the positive value to the end of the array is my positive value. And now we can return the max of this both. Yes, got some idea? Yes. So now our focus is to find this index and this index. But how can we find this index and that index? Just assume what is this and what is this? I can say this is immediate lesser number than 0. Immediate lesser number than 0. Whether minus 2 is immediate lesser number of 0? No. Minus 1 is the immediate lesser number of 0. After 0, there is only minus 1 in this array, which is a least difference to 0 in less number. Yes. And then what is the least that is the least greater number than 0? I can say this is the least greater number than 0. Yes. So this is greater than 0, which is a least number. It's a minimum number. So now we want to find what the immediate less than 0 number, 0 in this, and immediate greater than 0 in this. And this is what? The negative. And n minus this index is what? Positive. Because Take for example, this 0, 1, 2, 3, 4, 5, 6 and 6. Okay. Now, how many elements are left here? 2 elements. And what is the length of this array? Is 7. So 7 minus this in this is what? 5. So 7 minus 5 is equal to 2. So there are two positive values. So simple, right? So we can find the negative and positive value, and then third step is return the maximum. Now got some idea? Yes. Now we want to find that immediate lesser than 0 and immediate greater than 0 to find the maximum of them. Yes. Now let's focus on that part. Just assume the same array minus 3, minus 2, minus 0, sorry, minus 1, 0, 0, 1, 2. Now, in many sets we know that is lower limit and upper limit. Now, what is the midpoint? What's the midpoint? I can say the midpoint is 3. This is the midpoint because 6 plus 0, it is 6 divided by 2, it is 3. So this is my midpoint. So my mid is here. Now, what is my mid? My mid is 0, right? First of all, we are going to find what? This value. That is the immediate lesser than 0. Okay. So it is 0, right? It is 0. Whether 0 is a negative value? No, it is not a negative value. Okay, we want to find the negative value, right? So where should be the negative value if the mid value is 0? The negative value should be where? This side. Yes. So if target value is what? Greater than 0 or equal to 0. If greater than or equal to 0, I want to move where? I want to move towards left side. So to move towards left side, I want to shrink my upper limit to mid minus 1. Yes. Again. I have shrunken here my upper limit. Okay. Now again, what is my midpoint? I can say my midpoint is here. Now, yes. Now again, whether minus 2 is less than 0. Yes, it is less than 0. So now we got an answer like target value, sorry, mid value, sorry, here also mid value, slight confusion. Okay, mid value is less than 0. If it is less than 0, it may be my part of my answer, but still we can have a better answer at right side, right? We may have a better answer right side, but it may be my answer. So I will update that mid value in my answer, and we want to move towards right side. So just move right side. To move right side, just mid plus 1 and lower limit. Yes. So this is my all my code for to find this point. Yes. Now my lower limit is updated here. Here again my mid value is facing here. Again my mid value is minus 1. So I will update here. Yes. Again after updated, my L value will be mid plus 1 here, and then U is less than L. So my loop gets terminated. So this is what the code for what? The immediate less than 0 number. Yes. Again take the same example. Now we are going with the second step. What is the second step? We want to find the immediate greater number than 0, right? So 0, 1, 2, 3, 4, 5, 6. Now what is the midpoint? Here is my low limit, and here is my upper limit. What is my midpoint? I can say my midpoint is here. Yes, my midpoint is here. Now just observe if the mid value if the mid value is less than or equal to 0, I want to move where? I want to move towards right side, so that there may be possibility of a positive number, right? So because it is in ascending order, right? So we want to move towards the right side. Yes. Else we may find a value which is greater than 0. Like if this is the case, then I will shift this low pointer where? Here. Now my mid is where? Here. Yes. If my mid is greater than 0, then it can be my part of my answer, but still we have some better answer in towards the left side, as we find for the first step, right? So if this is the case, like mid value is greater than 0, then it may be my part of my answer, and also we can get a better option when I string my lower pointer, that is when I move towards left. That's all. So we have found out this both. Then now it's time to return the max, right? So what is the time complexity now? I can say time complexity is to find the first that is the positive index, it is log n. To find the negative index, it is log n. That's all. That's all about it. So it is 2 log n. We can also say that as O of log n. Simple. And what is space? It is O of 1. That's all. So this is the time complexity and space complexity. Yes. Now let's see the code. Just see here. I first explain the first approach. See here, n is equal to 0 and p is equal to 0. And for I in nums, if I is less than 0, just n plus is equal to 1. If I is greater than 0, p plus is equal to 1. Return p if p is greater than n, else n. Simple. We just taken the count of positive and negative. Just return whichever the maximum value. That's all. Let me run this first. This is a linear time complexity. Let me submit it. Yes, it is submitted successfully. Now we can see the binary search approach. And then the important thing in this binary search approach is, I forgot to say this. See here, if the start value of the array and the end value of the array is equal to 0, then what it means? It means there is no negative value, no positive value too. Do you understand now? Yes. So that's why I just trying to find out whether the first in this value and the last in this value is 0. If it is so, I just return 0. That's all. Okay. Or else I want to do some binary stuff. Okay. Just taken the length, then negative is equal to 0, then L comma R is equal to 0 comma n minus 1. Now wait, L is less than or equal to R. I found out the midpoint. Then if the mid value is less than 0, if mid value is less than 0, what should we do to get the immediate lesser number than 0? We want to find the immediate lesser number than 0. So if it is less than 0, I want to do what? Negative is equal to m, then L is equal to m plus 1, right? We have found out here, right? Where, see here, we have found out here, right? If it is mid value is greater than or equal to 0, then what should we do? We want to do the low limit to mid minus 1. Else we want to do what? We want to store it in the answer, then L is equal to mid plus 1. Yes, that's what I have written here. Just see here. Okay, understood? Now again, now we are going to find the positive value. Yes, now this is the code for the positive value. As I told in the logic, see here, if nums of m, this mid value, is greater than 0, then it can be my part of my answer, and we want to find a better option in towards the left side. Okay, else we want to go towards the right side. So that's what the case I have written here, right? I have written this yellow color, okay. Now after that, just here, after that, negative is equal to negative plus 1, because my negative is at where? At the index, right? At the index, always the number of negative values will be index plus 1. See here, what is this index? This index is 2. 2 plus 1, it is 3. So there are totally 3 elements, three negative elements, right? So that's why I have written this. And then positive is equal to n minus positive. I have told you in that logic building, right? If this is the value, this 1. Okay, what is the index? 3. Okay, what is the size of the array? This 6. 6 minus 3, it is 3. So we can find that number of positive elements, right? And then we want to return the max among the positive and negative. That's all about it. Let me submit it. Yes, hope you understand this concept. Thank you.